Hi, everybody. Thanks for coming tonight. We'll get going with our Green Living Seminar presentation tonight. I'm Dr. Elena Traister in the Environmental Studies Department here at the Massachusetts College of Liberal Arts. And our Green Living Seminar this spring is focused around the theme Rewilding Our World. All of these presentations are free and open to the public. They take place here in the Feigenbaum Center for Science and Innovation, room 121, on Wednesdays at 5:30 p.m. And you can find the schedule of our upcoming presentations on our website at www.mcla.edu/greenliving. Our presentation today will last about 40 minutes or so with some questions at the end, so please hold those questions and make sure to ask them after the talk. And before I turn it over to our speaker, I want to make a little plug for next week's presentation. On Wednesday, April 9th, Mark Winter, co-founder and owner of Recover Green Roofs, along with Emily Alstead from the same company, will be presenting a lecture titled Green Roofs, Rewilding Our Cities. Today's presentation, Restoring Rivers and Rewilding Wetlands in Massachusetts, will be given by Beth Lambert, Director of the Massachusetts Division of Ecological Restoration. Thanks so much.
Thank you, Dr. Traister. Well, it's great to see you, and thank you, Dr. Traister, for the warm welcome. I'm Beth Lambert, and I'm the director of a state agency called the Division of Ecological Restoration. And tonight, I'm going to be covering three things. I'm going to start by giving you some background on the Division of Ecological Restoration, what we do, and how we do it. Then I'll go into a little more details about river and wetland restoration, focusing mostly on river restoration and just touching on wetlands briefly towards the end. And then at the very end, I just want to touch on two local initiatives that are very innovative and creative and will bring big benefits to rivers in this region. So that's my plan, and there will be time for questions and discussion at the end. And what you see in this picture is some of the staff in my division, and they are posing at a road stream crossing, also known as a culvert or a small bridge. And this is a culvert that was constructed particularly to provide passage for fish and wildlife that are traveling along the stream corridor. And we'll be talking a lot more about culverts as I get into the presentation. Okay, so I'm going to start with some general background on the division. And the reason I'm talking about our division is because it's very rare to have a state agency that focuses on river and wetland restoration at all, but also to do that work in the way that our division approaches it. So our division was formed in 2009. We're part of the Department of Fish and Game, which is a larger state agency. And the Division of Ecological Restoration, or DER, which I'll say because it's shorter and easier, was formed in order to restore and protect rivers, wetlands, and watersheds for the benefit of people and the environment. We work in partnership with other state agencies, with towns, with nonprofit organizations, and with federal agencies across the state to carry out river and wetland restoration projects that help both people and nature adapt to climate change. I know that this seminar series focuses on rewilding, and restoration is a type of rewilding, or perhaps rewilding is a type of restoration. And so as we get a little further, I'll share with you the definition that we use for restoration, and I'm sure that each person who's spoken to you has shared their definition of how they think of rewilding and how they think of restoration. And so tonight, you'll hear ours. So this is how we think of ecological restoration at my division. This is the definition from the Society for Ecological Restoration. And so the definition that we follow is that ecological restoration is the process of assisting the recovery of an ecosystem that has been degraded, damaged, or destroyed. And in the case of our division, we focus on river and wetland ecosystems. So we're focusing on rivers and wetlands that have been damaged or degraded in some way. The approach that we use, and I'll come back to this later as well, is we try to understand the watershed where the river or wetland is located, identify the driving process, the processes that are really driving the ecosystem of that river and wetland. For example, the movement of water, the movement of sediment like sand and gravel and silt in the bottom of a river, the movement of organic material. We try to identify the major stressors and remove them where we can. And the goal is to have a self-sustaining system or project where we don't have to come back every year and sort of refix it, but that the nature is essentially able to pick itself up and move on after the heavy equipment finishes construction. So during the years since our division was formed, since 2009, we're just wrapping up our 15th anniversary year, we've developed expertise in certain types of aquatic habitat restoration. And we focus on these because these are critically important to the rivers and wetlands of Massachusetts. The things that we focus on are dam removal, coastal wetland restoration, like salt marshes, the restoration of former cranberry farmland into thriving natural wetlands. That's more of our rewilding work. We focus on upgrading undersized and failing culverts, floodplain wetland restoration, and more we focus on helping municipalities, nonprofits, and others come together to build partnerships at the watershed and regional level to carry out restoration themselves. All of the work that we do at our division takes place by working in partnership with federal, state, local communities, watershed associations, and many others. And by partnerships, I mean that our staff and our partners work together as a team across all levels of government and community organizations. Every project that we do has a team behind it, and that team usually includes a nonprofit such as a watershed group or a Trout Unlimited chapter, state agency staff such as my staff, federal agency funding and often federal agency staff, municipal staff, and we all work together as a team with each organization contributing what it can to get the project planned, designed, and constructed. And so the photos that you see here on this slide illustrate some of that teamwork. The upper left is a photo of my staff and federal staff meeting in the offices of the Jones River Watershed Association, which is in southeastern Massachusetts. And so in that photo, I see the executive director of the Watershed Association, I see a federal agency colleague, I see my staff person, Georgianne, and I see an engineer. And so projects often take place around offices or sometimes around kitchen tables with everyone coming together. The upper right, that ribbon cutting is in Falmouth. The woman cutting the ribbon is the woman who coordinated the restoration project on behalf of the town. In that photo, I see a federal staff person, I see the director of the local watershed group, and I see a local legislator. The bottom right, that photo is a project team from a dam removal in north central Mass, and the team includes Trout Unlimited volunteers, the Conservation Commission members from the town, the conservation agent, and a state person who focuses on land protection. So every project that we do is in partnership. We work all across the state, and you may or may not be able to read the legend, but the blue circles are river restoration projects that are underway right now, being planned and led by our staff. The green squares are wetland projects, and you can see that most of those are either on the coast, in which case they're salt marsh restoration, or they're in southeast Mass, in which case they are former cranberry bogs. And then there's one green square sort of in central Mass, and that's near Northampton, and that is a floodplain restoration project. And then the orange triangles are all culvert replacement projects that are going on across the state. And over the last 15 years, we've worked in over 160 towns around the state and completed 160 different restoration projects. And we've got around 80 projects in planning right now. So the way that we do our work is we focus on three things. Number one, our staff manage river and wetland restoration projects. So we work with the landowner, we hire the engineer, we oversee engineering, design, permitting, we guide and contribute to public engagement and community outreach. And restoration projects are complicated to manage, and so our role is kind of like the bus driver or the orchestra conductor, basically getting the project done. We also, because even though we're a pretty big program, we're 30 people, there's far more need out there in the state, far more interest in river and wetland restoration than our staff can support. So we also work to build the capacity of other organizations and towns so that they can lead these types of projects themselves. And then the third thing that we do is share the restoration knowledge that we've gained over the years with people that need that information to lead restoration projects themselves. And so that is our three-pronged approach, or our three areas of emphasis in order to ramp up and expand river and wetland restoration across the state. That work relies on, of course, having solid operations in our offices, and it relies on having reliable, steady funding from the state of Massachusetts, from nonprofits and from other organizations. So just to go into this as an example, this is a dam removal that took place in Northampton. And so our staff worked with the city, which owned the dam, to assess the feasibility of removing it, to plan the project, to oversee engineering and design, to get the project through permitting, and then to help the city put it out to bid for construction. This particular project took around 10 years to plan. And that's an example of a project where our staff are really managing the project in partnership with the landowner. For building capacity of others, this is one of our staff working with Department of Public Works staff from across the state to help them understand how to assess and replace undersized culverts with larger, safer structures that provide fish passage. A culvert is a structure that carries a river or stream under a road. And so you can see a culvert in this photo. Everyone in the green vests are town Department of Public Works staff from around the state. And then our staff person is standing in the stream in the knee boots explaining how to assess culverts to see whether they're allowing fish and wildlife to move through. And then, like I said, we also share our restoration knowledge. And so we often do that through training, by providing input to other restoration projects and similar activities. This is an example of a training that we're involved in right now. There's an online webinar series called Dam Busters. And my division has been partnering with the Massachusetts Rivers Alliance and the Charles River Watershed Association to put this series on monthly. Last year was Dam Busters 101. It was an overview of the dam removal process. This year is Dam Removal 201, where we're getting more into the science and the technical aspects of removing dams. So that's an example of how we try to share our knowledge with people that need this information to manage their own river and restoration projects. And then just to share what we've accomplished, just for examples of how these approaches work together. For 2024, we had 9 river and wetland projects under construction. That was 3 dam removals and 3 wetland restoration projects on former cranberry bogs. We completed 5 projects, including 3 dam removals and 2 wetland restorations. And this year we had 49 projects in various stages of planning. In addition, we reached 3,000 people through outreach and community engagement activities. We worked with 53 different towns. We restored 103 acres of freshwater wetlands, removed 3 dams, and reconnected almost 38 miles of river by removing these barriers. If we look at our 15-year total, then over the last 15 years, by working in partnership with all these organizations and agencies, we've restored over 3,000 acres of wetland around the state. We've awarded over $77 million in funds to advance restoration projects. Those grants go to cities, towns, nonprofits, and landowners. We've removed over 65 dams. And the work that we've funded through awarding those grants is projected to have created or maintained over 900 jobs around the state. Lastly, we've advanced more than 120 culvert replacement projects and reconnected 700 river miles by removing barriers. So before I start diving into talking a little bit more about specific project types, I'm going to talk about dam removals, culvert upgrades, and then a little bit about wetlands. I just want to touch base on the ecological restoration approach again. So I said at the beginning that we try to understand the site where we're working. We try to restore natural processes, understand the ecosystem drivers, and come up with a self-sustaining restoration approach. We also invest in other project benefits, and those include things like public safety, recreation, outreach, climate resilience, and we monitor and share results. So since we're an aquatic habitat restoration program focused on rivers and wetlands, for us, the driving ecosystem process that we're trying to restore really comes down to the movement of water. Rivers are long linear ecosystems that rely on being connected from their headwaters to their mouths. Wetlands rely on unique hydrology that creates wetland habitat. And tidal wetlands, coastal wetlands, rely on the movement of salt water in and out of salt marshes. So to restore rivers and wetlands, for us, it's really all about restoring those basic processes, figuring out what's impeding the flow of water, and removing that stressor. So that's why we choose the project types that we do. And so I'm going to focus on dam removal and culvert upgrades for the next few minutes in this presentation. When we think about our approach to ecological restoration and restoring the free flow of water, dams and culverts, well, if rivers are like the lifeblood of our ecosystems and our communities, dams and culverts are the cholesterol that clog up the veins and arteries. And like cholesterol, they can really damage, just as cholesterol damages the human body's ecosystem, dams and culverts damage river ecosystems. So one of our major areas of focus is unblocking river systems and allowing for the free movement of water, sediment, organic materials, and fish and wildlife by removing dams and upgrading culverts. And so that's what I'm going to focus on next. I'll start with dams and dam removal, and then I'll talk about culverts. So Massachusetts has more than 3,000 dams, and I'll show you a picture of what some of these dams look like in a minute. And this web map that you're looking at here on the screen is a tool that we have on our website to help people evaluate the benefit of removing any particular dam. So that's why these speckles, these dots are all different colors. The circles that are coded red, those are the highest, those bring the highest ecological benefit if the dam were to be removed. And then the smallest circles, which are gray, have the least ecological benefit, although all dam removals will have ecological benefit. So the reason we have so many dams in Massachusetts is because they were built in the 17 and 1800s, soon after settlement, to power mills. Of those dams, fewer than 10% provide flood control or provide a drinking water benefit. So the vast majority no longer serve the purpose that they were built for. They've been aging, and they're in bad shape. They create a public safety threat if they were to burst catastrophically. And they have enormous ecological damage for our rivers. Dams create stagnant water habitat. They damage water quality. They block fish and wildlife from being able to move up through the river corridor. They drown the floodplains that are upstream from them. And essentially, the native fish and wildlife ecosystem can't thrive in these ponds that are created by dams. This slide shows examples of some of these dams. These are actually all dams that have been removed. They were all built originally at some point in the 1700s or 1800s. Some were rebuilt later. And these are examples from across the state. And so the interesting thing about dams is that they were built soon after settlement. And this painting shows kind of this iconic New England village with a dam and a water wheel and a mill right in the center of town. And many of our towns grew up around mills and dams. And these mills and dams were small, and they were used to cut lumber and to make nails and other small sort of locally driven manufacturing processes. And then over time, as the economy changed, mills stopped being sort of local mills and instead consolidated and became a big center of industry in Massachusetts. And so those local dams, the small dams on small streams, were basically abandoned where they were as industry shifted into these larger mills built on larger river systems. No one took down the dams when this happened because there was no rule and people weren't really thinking about impacts to river health at that time. So eventually the economy shifted into these large manufacturing centers, and then eventually manufacturing shifted away from rivers and New England altogether. Meanwhile, though, those abandoned dams continued to age, and when we reach the 21st century, as the climate changes, storms are putting more and more stress on these aging dams, and dam owners are responsible for keeping them in good repair. But because there's no purpose to the dams, that puts a dam owner in the position of putting a lot of money to keep something in good repair that they're not actually going to use and gain economic benefit from. So the majority of dam owners would prefer to remove their dams if they can. From an ecological restoration perspective, removing a dam is one of the best things that you can do for a river or stream. So our division works with dam owners where there's significant ecological benefit, particularly benefit that is sort of statewide significance. We help them through the dam removal process. Dam removal is a 5-year or longer process, not because that's how long it takes to take down a dam. The dams in this photo came down in days to weeks. But the process of engineering and design and permitting can take more than 5 years. But this is what our staff do, is we help dam owners through this process. We oversee engineering and design. We help dam owners interpret the results of these various engineering studies. We help through the permitting process, through public engagement. We write a lot of grants so that there can be incentive funding for dam owners. And then finally, we help the dam owner when it comes time for removing the dam through construction. So there's basically 2 ways that we help dam owners. The first is that we, for free, provide basic reconnaissance studies for dam owners. This program is aimed at municipalities, so cities and towns that own aging dams. And we do basic studies that assess the feasibility of removing the dam and give the city or town a cost estimate of what it would cost, along with information about sort of technical challenges and how the project would need to address those challenges. And we do that free of charge. Dam owners apply on an annual basis, and we choose projects that will improve public safety and also bring significant ecological benefits. After we do that study for the dam owner, then there's no obligation for them to then remove the dam. It's really a tool to give them so that they can make a decision on how they want to proceed. For dam owners that have decided they do want to remove their dam, they can apply to work with us basically for the project. It's not a grant program per se, it's a project program. So they can apply to us for their project, and then we guide it through the process, as I described on one of the last few slides. We see it through from beginning to end. And our staff are working on 22 dam removal projects around the state currently. We also work to build the capacity of others, and we do that through trainings, such as the Dam Buster series that I mentioned earlier. We're also creating a dam removal community of practice, and that's for people who are leading dam removal projects around the state to come together to talk about the challenges that they're running into and help each other problem solve. And then in the future, we'll be developing additional trainings, putting tools and things online, and other ways to help kind of expand dam removal and dam removal assistance. So the last thing I want to show before I get into culverts is what it looks like when you remove a dam. This is a photo sequence starting with 2010 in the upper left corner. That's a picture of what was called Hopewell Mills Dam. The dam was removed in 2012, so you can see the heavy equipment there chipping away at the dam. The former impoundment, so the dam created a pond, and when the dam comes down, the pond drains and becomes a river. So you can see in the second 2012 photo, the equipment digging the new river channel through the former pond formed by the dam. And then the picture on the right in 2023 shows what that exact site looks like today. So the amazing thing, back to our approach to restoration, is that once you remove the dam, the river becomes a river immediately. The free movement of water starts, the stream starts transporting sand and gravel and cobbles. It's often able to build its own habitat. And in 10 years, you can't even tell that there was a dam there. That process starts right away, so you see the river heal immediately. But after 10 years, the trees in the floodplain have grown up. These trees here in this photo are taller than I am. And I went out there to take my photos, where I always take them every year, and I couldn't figure out where I was supposed to stand because I had previously taken my photos near the old dam, and I couldn't find it. It just looked like a natural, healthy river. So now I'm going to transition to talking about culverts. Culverts are defined as a pipe or a similar structure that carries a river under a road. And this is a picture of a culvert in Beckett. And actually, the governor is standing on top of the culvert in that the orange vest there. And she's announcing new funding for culverts for cities and towns in this photo. And this is an example of a culvert that was replaced a few years back to reduce flooding in the local community. I said that Massachusetts has more than 3,000 dams. Well, Massachusetts has more than 25,000 culverts. This slide shows you those culverts. On average, this means that every half mile of river, there is a road crossing it, and that road crossing it crosses it either by a bridge or a culvert. Of these 25,000 culverts, we estimate that at least half are undersized or failing and prevent fish and wildlife from being able to get upstream. It's not only fish that use rivers to travel. Small mammals like foxes, raccoons, mink, all other species prefer to travel by river corridor. They like those riparian areas. They like the trees and the shrubs along the river. So when there's a culvert that Fish and Wildlife can't get through, they can't move to the habitat that they need to get to live out their life cycle. For mammals, what they'll often do is, if they can't get through the culvert, they will climb up and over the road. And so if you're driving along and you see roadkill on the road, it's often because there was a deer or a fox or a raccoon or a beaver that was trying to travel along the river corridor, couldn't get through, and went up and over the road, getting hit by a car in the process. So culverts are not just about fish, they're also about wildlife. And so this picture just shows you 3 examples of what we would call bad culverts, where there's either a drop at the end of the culvert. So if you were a fish, you would have to jump a couple feet to get into the culvert and continue upstream. Or if you were a deer, you wouldn't be able to get through it all. Or the photo in the lower right, the concrete around the culvert is cracking. So that is going to eventually fall in. Or, as in the upper right, the culvert is undersized. And when a culvert is undersized, it's not big enough to carry the river or stream. And during floods, that culvert acts as a bottleneck, and the river piles up behind it, and then either takes out the road or floods the road. So my division is involved in improving culverts for ecological reasons. These are definitely the cholesterol in the veins of rivers. But towns are very interested in this exact same work because of the connection with road safety. And so we're able to work together with towns in work that meets both of our goals. Massachusetts actually has standards for culverts that towns must meet if they're replacing a culvert. And those standards ensure that the culvert will be passable by Fish and Wildlife. The photo in this slide shows you an example of a culvert that meets the standards. Basically, it's big. Like, that's the take-home message. The culvert spans the stream. It's basically invisible to the stream. The stream can just flow through. It's totally unimpeded. Fish and Wildlife can get through with no problem. And so the standards are designed to help towns build culverts that meet that. They're very expensive, though, and they're also technically challenging. And so our goal is to help towns learn how to do these kinds of projects, knowing that that will benefit public safety and road safety, and also restore habitat for fish and wildlife. And this is an example. The culvert on the top is falling apart, and there was a drop at the outlet so that if fish were trying to swim upstream, they would have to try and jump a foot. And then the picture on the bottom is after that culvert was replaced with a larger structure that is open at the bottom and allows fish to get through. So through our work with culverts and towns, we've awarded grants to towns across the state to incentivize this type of work. We don't have enough money to pay for the whole cost of the project, but often if we can offer an incentive, the towns can find the rest of the money. We've awarded 166 grants for 134 culverts. That's small compared to the total number of culverts, which is 25,000. But what we're trying to do is help towns learn how to do this work themselves, so that if we help them the first time, they'll be able to do the other culverts in their town without needing as much help. So every grant that we award comes with a staff person from my division that helps the town get through engineering and design and permitting. Recently, there's been a boost to funding for culverts. 2 weeks ago, the governor announced $200 million that is going to go towards culvert replacements for the benefit of safety, resilience to climate change, and biodiversity. The average cost of a culvert is around $1.2 million. So $200 million, even though it's a ton of money for culverts, is still a drop in the bucket. It'll fund around 160 culvert projects. But it's way more than the state has ever invested in this type of work before. So those are the types of projects that focus on rivers and streams and reconnecting them from headwaters to mouth. Before I close, I just want to touch briefly on some of the wetland restoration and rewilding work that we do. A lot of our wetland rewilding work focuses on former cranberry farmland in southeast Mass. Freshwater wetlands are notoriously difficult to restore. You have to have the hydrology, the movement of water has to be completely correct in order to restore a wetland. And there's a variety of other factors at work, such as stormwater, invasive species, other challenges that can make wetland restoration very difficult. Cranberry farms, however, are perfect places to restore wetlands because they were originally peat wetlands in southeast Mass. And once you undo the impacts of farming, there's essentially a wetland there just waiting to happen. So this is an area where we've focused a lot of effort over the last few years. The pictures in this slide show you what cranberry farms look like. You can see that the stream channels running through them have been somewhat straightened. You can see that there's a monoculture of cranberries. You can see that the land has been sort of artificially flattened and graded. So the work that we do takes out water control structures. It removes sand that the cranberry farmers apply to stimulate cranberry growth. And underneath that is peat. And the hydrology is typically there already. And so between the peat being present and the hydrology, with just a little bit of action from heavy equipment, the wetland will basically self-restore and will burst into life. So this is an example of what it looks like during construction. So picture this in comparison to the cranberry bogs. One thing I will say, cranberry bogs are very tidy. They're very neat and tidy. Nature, however, is messy. And so a lot of what we do in cranberry bog restoration is recreate the mess that would have been there and use that mess to jumpstart the wetlands. So this is what it looks like during construction. You can see it is quite messy. And then within 1 year, this is what it looks like. So with the peat and the hydrology already in place, the wetland basically restores itself. We don't have to plant anything. The seeds are already there in the peat. And we don't have to use water control structures because the hydrology was there already. Before I close, I just want to touch briefly on 2 local restoration initiatives that are very innovative and creative. The first is the Berkshire Clean, Cold, and Connected Partnership. Are any of the guests in back involved in Berkshire Clean, Cold, Connected Partnership? Nope. How about the Hoosick River Revival? Excellent. Okay. So the Berkshire Clean Cold Partnership is a group of watershed associations, towns, and the regional planning agency, the Berkshire Environmental Action Team, and Trout Unlimited coming together to plan and carry out restoration work throughout the Berkshires. This group includes the Hoosick River Watershed Association, which is the watershed that we're in right now, the Housatonic Valley Association, the Farmington Watershed. Berkshire Environmental Action Team is based in Pittsfield, bringing all those organizations together with the Regional Planning Agency. And they have identified something like 50 or more culvert replacement and dam removal projects throughout this region, and are beginning to work with towns and landowners to get those projects started up. DER is supporting this partnership with grant funds so that they can hire a staff person, because cities and towns want to do this kind of work, but they lack the staff, and they often lack the specific technical information that you need to carry out these projects. And so by helping this partnership gain staff, that's kind of the catalyst needed to actually do these projects. And then the Hoosick River Revival is an amazing initiative to remove the flood chutes from the Hoosick River where it flows through town here, and replace that with a flood control solution that helps restore river health, makes the river more accessible to the community so that it's not trapped in these concrete walls, and can act as sort of the jewel of North Adams, helping to revitalize and energize the city's cultural and economic vitality. This is a project that's been in planning for many years, probably at least 15 years, possibly 20, and will continue to be in planning for many years. But when complete, instead of seeing a trickle of water through concrete chutes, which is what you see currently, you should see a vibrant and living river with fish and birds and wildlife and places for people to access the river, while also still having a flood control system along it that will protect the town from flooding. These are two amazing initiatives that are focused on restoring rivers here in this region. So in closing, I just want to sort of recap what I covered tonight. I spoke about the Division of Ecological Restoration and how we work with communities and partners to plan and carry out projects. I focused in for a little bit on dam removal and culvert replacement as two critical activities that are needed to restore river health. And then lastly, I touched on cranberry bog restoration and a little bit about some of the work going on in this region. So thank you very much.
And we have time for a few questions.
What's the difference between a culvert and a bridge?
That's such a good question. So the thing is, the bigger the culvert, the more it starts to look like a bridge. So the culvert is traditionally, so that would be called an open bottom culvert, actually, that structure in that photo. And I think it has to do with how it's built. So in this case, it's cast as a complete structure, a single structure with the supports being part of the top, as opposed to a bridge where you might have decking on top of piles. So, but what we're aiming for really is for culverts to look like bridges. We want them to be open bottomed and we want them to be wider than the stream, essentially. But at the small side, a culvert is just like a pipe.
When you're removing a dam or restoring a wetland and just letting stuff grow back on its own, do you have to do anything to mitigate invasive species?
Yep, and we definitely do plant trees and shrubs depending on where the project is taking place. So if the project is taking place in a place with a lot of invasives, then we would plant native plants and come back year after year over maybe 5 years to make sure that the native plants aren't encroaching on them, and non-native plants, and give the native plants a chance to really establish. Some places, if there's not invasives, you can really let Mother Nature do the work, and then just sort of monitor it to make sure.
So that's an amazing number of dam removals, miles of river connected. Has there been research looking at how that's changed the movement of fish and like any expansion of the diatomous species?
Mm-hmm. Yeah, there has been in a few specific spots. So for example, one of the projects that I worked on was in Taunton on a stream called the Mill River. And as part of that project, we removed 3 dams to allow river herring to get upstream to what would have been their spawning habitat. River herring had been completely extirpated from the watershed because those dams didn't have fish ladders. And what we've seen across all sites is that fish return immediately to the habitat. And so we actually, at this site, we made a plan to monitor the return of river herring over a 7-year period. It would be so much fun to do like 20 years, but we had funding to do it for 7 years, and we installed a camera, underwater camera right upstream. And so after the first dam came out, The very next year, we caught on camera a river herring moving past that spot. Once all 3 dams were out, we installed another underwater camera. And so what we found is that the watershed over a period of 5 years went from 0 river herring to 30,000 river herring per year. River herring are the foundation of the ocean food web. Healthy river herring populations are critical for larger species, and they provide that link between the energy and the nutrients on land. They bring that out to the ocean where they are consumed. So to be able to have that kind of response is really incredible. And this is like a semi-urbanized, this wasn't pristine habitat. This was a stream with other problems. Yes?
So when you see results like this, do you feel like sometimes we're just overthinking a lot of stuff? I'm just spitballing here.
Yeah, I think Mother Nature, or nature, we don't have to call it mother, but nature, I think, is so resilient. And with a little bit of help, when you're removing the right stressor, Mother Nature bounces back, and it's one of the most powerful things to watch. And so the fact that there is so much environmental degradation and damage to ecosystems is a reflection not of the sensitivity of nature, but of the widespread impact that people have had. Because when you remove that, nature turns out to be strong.
In light of the example you just gave, it seems that you'd have to be, you could maximize the environmental impact of your work by being highly strategic about where you did things. Mm-hmm. So you could, and given that the number of bad culverts and bad dams you've got to remove and your limited resources, it seems like you might end up concentrating most of your work in one part of the state because you could then maximize the impact, but neglecting other parts. How do you balance that calculation?
Yeah, we have conversations about things like that all the time, but we're a statewide program, and our mission calls for us to restore rivers, wetlands, and watersheds for the benefit of people and the environment. And so we serve the people of Massachusetts, not Western Mass or Northeastern Mass or Southeastern Mass or Cape Cod. So we strive to work statewide, and ecological benefits are just as important in urbanized environments as they are out in the wild. And people in urban settings deserve to have free-flowing rivers just as much as beautiful forested cold water streams. So it's sort of a constant tension between wanting to serve the whole state and also reaching for the most ecological benefit that we can get. Any other questions?
So, a couple. I guess the first one is, so you mentioned the floodplain restoration project.
Mm-hmm.
Could you say a few more words about that?
Yeah. So we are interested in restoring floodplain habitats and floodplain wetlands. And so we partnered with Mass Audubon in Northampton at the Arcadia Sanctuary. And the hydrology, so we wanted to restore native vegetation in a place where the hydrology was already present. So we looked at the stream flow patterns and we looked at the elevation of the floodplain to make sure that the floodplain would in fact be inundated regularly. And then we worked with Mass Audubon to plant native trees and shrubs in what had been agricultural land previously. And so that sort of created it plugged a gap in natural and conservation land. So we're trying to create kind of a corridor of natural habitats from the uplands down into the floodplain and out to the river, so that wildlife could access, if they lived in the uplands, they could use this network, this corridor, to get all the way to the river. And so that's what this floodplain restoration did.
I don't know if you're familiar with the spruces in Williamstown. It was a floodplain that had a trailer park on it for many, many years. It flooded badly in, I think, 2011. And so they closed it down. They took out all the homes, and it has become a de facto town park. All people love it. But it seems to me that on the upstream side of it by the river, there's a levee, concrete and dirt levee, that prevents it from actually flooding, except in very extreme circumstances. And I'm just curious whether it would make sense to take at least some of that out, or create gaps in it to let the water in.
Yeah, that we have done that type of work in other settings. I'm thinking of a project along Amethyst Brook in Amherst, and yeah, I mean the key would be just making sure that if one did that there weren't homes or infrastructure relying on that. Yeah, but yes, that's definitely one way to remove a blockage and restore the natural movement of water and get that floodplain hydrology back.
I thought the part about restoring the cranberry bogs is like so cool, how they just like bounce back after like a year. I'm wondering, are you really just going in there and like restoring the flow of water to what it should be? And that's
It's so the sort of yes and no. So the way cranberry farms are managed is that farmers put sand on them every year to stimulate cranberry growth. And so they were originally peat bogs, and then through, say, 100 years of cultivation, they have, a foot or two of sand on top of that peat, spread across. And then the other stressors are water control structures that the farmers put in so that they can flood the fields, and ditches that they put in so they can keep them drained, and then straightening the stream channel. So the steps that we usually take are to remove that sand. And so the wetland is still underneath there. It's just been buried in sand. And we fill those ditches that were sort of draining that wetland. So that brings the water table back to where it was or needed to be or could be. And then often, not all the time, but often we will re-meander the river, which has been straightened, and add large woody habitat to it, because in nature, rivers are usually have wood in them. And then we step away. And so the wetland is really under there already. It's just getting rid of that sand and filling the ditches and getting out like water control structures that the farmers have built. So it's pretty amazing to
that's
see.
super cool.
If that's all the questions, then I would once again thank Beth for coming and presenting tonight. Thanks for all the great questions. And if anyone does have any questions that they want to just ask individually, I think Beth will stick around to do that. So thanks so much for coming back.